Hey guys, today we are looking at evaluating and graphing polynomials. So we're going to look at some different properties and what they do to form polynomials. So special types. These all have special names. They're all types of polynomials. So a constant has a degree of 0. And that's like if you just have y equals 2. A linear would be a degree of 1. That would be something like y equals 3x plus 2. We saw a lot of linear functions and linear polynomials in Algebra 1. Quadratic is something we talked about a lot in Chapter 1. That would be like y equals 7x squared minus 3x plus 2. So that has a degree of 2. The highest degree there, the highest exponent we see is that degree. So a cubic function would be something like 6x to the third plus 7x squared minus 3x plus 2. Quartic, so a degree of 4. Could be something like y equals 15x to the fourth minus 7x squared plus 3x minus 2. I want you to notice I skipped over the cubic there. You don't have to have all of those degrees. So I skipped over the 6x cubed in that case. You can, as long as the highest degree is that number, that is what kind of polynomial it is. You don't have to have all of them listed out. So note, it is not a polynomial if it has the square root of x, some constant, some number divided by x, some number to the x power, or it has x to a negative number. All of those things make it not a polynomial. The exponent has to be a whole number. So classify these polynomials. So in this first one, I see x to the second, and then I see x to the negative 2. Well, x to the second is the highest power, but that x to the negative 2 is a big red flag. That tells me this is not a polynomial. Okay, and then on B, I see x to the second, and I see x to the fourth. 5 radical 2 is just a constant. So x to the fourth is my highest exponent, so that's a degree of 4, so that is a quartic. So ways to evaluate a function. If we want to find f of negative 2, notice we have replaced the x with a negative 2 here. So that means in this problem, we're going to replace every x that we see with a negative 2. So f of negative 2 is equal to 3 times negative 2 to the third minus 2 times negative 2 plus 1. So negative 2 to the third is negative 8. Now, 2 times negative 2, that would be a plus 4 plus 1. So I get negative 24 plus 4 plus 1. So that would be negative 19. That is called direct substitution. That's one way we can evaluate. The other way we can evaluate functions is using synthetic substitution. Synthetic substitution is one of my favorite things that we do in here because I think it makes it a whole lot easier to plug in values. So synthetic substitution works like this. If we want to evaluate when x is negative 2, we're going to put negative 2 up here in its own little box. Then I'm going to pull all of the coefficients off of this function. So I have 3x to the fifth, and then I have a negative 1x to the fourth. The key here, though, is including all of the coefficients. So I have 0x to the third I have 0x squared, I have negative 5x to the first, and then I have positive 10. So I pulled all of those coefficients off. Now you're always going to draw an arrow down off of the first coefficient. That 3 goes directly down below. Then we're going to multiply the 3 by that number in the box. So 3 times negative 2. We're going to put up here as a negative 6. Then we're going to add these two numbers. So negative 1 plus negative 6 is a negative 7. And then I'm going to multiply again by that box. So negative 7 times negative 2 is a positive 14. 14 plus 0 gives me 14. Then I'm going to multiply by negative 2 again. So I get a negative 28. 0 plus negative 28 is negative 28. Negative 28 times negative 2 is a positive 56. And then I have negative 5 plus 56. That's a 51. 51 times negative 2 is negative 102. 10 plus a negative 102 is negative 92. So when you multiply, so if you want to, go ahead and put negative 2 in and use direct substitution and see if you get the same thing. And you could go back on example 1 and try to use synthetic substitution and see if you get the same number there as well. Both of the methods work to evaluate for certain values. Another thing we're looking at is end behavior. So end behavior is what happens to graphs as we reach the edges. So when x approaches infinity, so as we head all the way out to the right, what is happening to the y value of the graph? Where is it going? So if you picture this parabola, I'm going to draw it in over here. I have x squared. So as I'm heading all the way to the right here, my graph is going up to the sky. So as x approaches infinity, my y value, or f of x, is also approaching infinity. As I go all the way to the right, I'm going all the way up. Then as x approaches negative infinity, f of x approaches what? So if I look, I'm going all the way to the left, my graph is still skyrocketing up in the air. So it approaches positive infinity. All of your functions are going to be structured like this. So look at part B. It says negative x squared. So if I draw that graph in, that negative x squared tells me that I have just flipped over the x-axis. I reflected over the x-axis. So as x approaches infinity, as x goes all the way to the right, then my f of x, my y value, is going all the way down, which is negative infinity. As x approaches negative infinity, as it's going all the way to the left, my y value, f of x, is going down as well, so negative infinity. Now x cubed, and this may be something that you haven't seen before. If you haven't, go ahead and put it in your calculator. Sometimes you'll hear this referred to as the John Travolta. It looks like this. So your graph is going in opposite directions. But as x approaches positive infinity, as it's going all the way to the right, f of x approaches positive infinity. It's going all the way up. As x approaches negative infinity, if I look at the left side of the graph, it's going down. So f of x approaches negative infinity. Looking at the same thing here, this final graph, we're reflecting over the x-axis. So it looks like this. As x approaches positive infinity, as it's going to the right, it's going all the way down. So f of x approaches negative infinity. As x approaches negative infinity, going all the way to the left, f of x is going up. So f of x approaches infinity. If you continue with this pattern, if you look at x to the 4th, I encourage you to go ahead and plot that in your calculator. Or you look at x to the 5th, or x to the 6th, or x to the 7th. What you should notice is that for all even graphs, they follow the same end behavior as x squared. So x to the 4th, x to the 6th, x to the 8th. Both ends are going up or both ends are going down. If you look at x to the 3rd, x to the 5th, x to the 7th, and so on, they're going in opposite direction. So if one is going to the right, the other, or one is going up, the other one's going down. And depending on which way it's flipped over determines what it is. So check those out in your graphing calculator. And then here's what you will see as some of the problems that we have to do. So determine the end behavior of the following. So we're looking for the largest degree there. So our largest degree is x to the 5th. So we're thinking that John Travolta graph, it's not flipped, it's not reflected, so it's looking like this. So we're going to say as x approaches infinity, f of x, so as it's going all the way to the right, it's going all the way up. F of x approaches infinity. As x approaches negative infinity, as it's going all the way to the left, f of x is going all the way down. It's going to negative infinity. All right, on this one, I have x to the 6th, so I'm immediately thinking x squared going in the same direction, but I see that negative in front of it. So that tells me that it's flipped over. So that means as x approaches positive infinity, f of x is going to be approaching negative infinity. As x approaches negative infinity, f of x is also approaching negative infinity. So last piece, determine the general shape by using end behavior. Create a table of values using the table function on graphing calculator. So to determine the general shape, we're going to look and see, okay, so we have an x cubed as our largest. That means we're thinking John Travolta. It's not flipped over. So that means over here it's going to be headed to infinity. Over here it's going to be headed to negative infinity. So I would encourage you to type that into Y1 in your graphing calculator and then go into table and find some values. So I have 0, 1, negative 1, 2, negative 2. You can pick any values you want. For 0, I get 3. For 1, I have 5. For negative 1, I have 5 as well. For 2, I have 17, which is probably a little far off the graph. For negative 2, I have 5. So you're going to want to to graph this on your graphing calculator to see what it looks like, because we don't know yet how to come up with all of these values and all of these terms that we may have. I'm going to skip over this 217. So, and I'm not sure what it's doing here. It could be doing something like this. That could be what the function looks like. Got this little piece hanging out here. What I notice is that it's going forever in the x direction and it's going forever in the y direction. So my domain is from negative infinity to positive infinity, and my range is also from negative infinity to positive infinity. There's no restrictions on your domain with that cubic function. Alright guys, that's all I have. We'll cover that graphing calculator activity in class. If you have questions, feel free to come in and see me. I'll see you in class.